So statement 1 can be simplified to P is less than 9Q upon 16. Now see 9Q upon 16, if Q was positive, then 9 upon 16 means reducing it. Therefore, one may feel that Q is being reduced and then it is greater than P. So originally it must be greater than P and therefore no would be an answer. That's not correct, because if Q were negative integer, for example, Q was a minus 16 and P was a minus 10, then when you do a 9Q upon 16, then the value of Q becomes minus 9, whereas value of P is minus 10. So in such a case, P is greater than, P is not less than Q. In fact, P is greater than Q. Originally it was minus 10 and this is minus 16. Okay. So in a number like, say, P is equal to, in a case like P is equal to 10 and Q is equal to anything 100, this would still hold. In this case the answer would be no. In this case the answer would be yes. Yes and no both are possible, so statement 1 is not sufficient. Come to statement 2. Statement 2 can be simplified to P is less than 44Q upon 35. Now see, 44 upon 35 means approximately 1.2 times. So roughly it can be written as P is less than 1.2Q. Now see, Q is greater than P when it is multiplied by 1.2. So originally it is possible, for example, P is equal to 11 and Q is equal to 10. So it is possible that originally P was greater, but on being multiplied by 1.2, Q became greater. So in this case the answer would be yes, P is greater than Q. However, in something like this, that P is equal to 10 and Q is equal to anything bigger, 20, in this case the answer would be no. So yes and no both are possible, so once again not sufficient. Now when I combine, see in this case this means P is less than roughly 0.5Q, and here it means P is less than 1.2Q. So in case P is a positive integer, positive number, then here, or rather let's say in case Q is a positive integer, positive number, then here while multiplying by 0.5, Q is being reduced. On being reduced also it is greater than P. Therefore if both are positive, something like this, if both are positive, then Q is more positive. And if both are negative, suppose something like this was the exception because of which statement 1 was not sufficient. Now this no longer holds, because now on being multiplied by 1.2 also, if this were the case, on being multiplied by 1.2, this will become roughly minus 19.2. Okay, and in this case 1.2 Q will be no longer greater than P. So such values are not possible, because see, when they are, when it's negative, then multiplying by 1.2 means you are reducing it. Okay, so on being reduced also it is greater than P. So even if they are negative, it means Q is far less negative than P. For example, if P is equal to minus 10, Q would be something less negative, something like minus 8 or so at least. So that minus 10 is less than, in this case, minus 9.6, So in both the cases now, whether P and Q are positive or negative, in both the cases I am getting no as an answer. We are getting no, P is not greater than Q, in fact Q is greater than P. So combining it works. This is a difficult question. There's a lot to be learned from this particular question. Be very clear about this one. If you can solve this one, you can solve most inequations questions that appear on the GMAT.